Hello guys, good afternoon. Uh, Today I am going to teach you how to use Packet Tracer to get Cisco networking devices to be able to use the networking devices or to be able to use the console and perform certain basic configurations on a router and a switch. Now through this process I am going to educate you on the features, how the Packet Tracer workspace looks like I demonstrated to you in our earlier classes. And then we'll use the opportunity to provide the initial configurations on any one of these devices. So the first thing is to go to Packet Tracer and then you double click on Packet Tracer to open. So this is the main page of the Packet Tracer. This is the working area. Now when you come to the down here, right, as you hover your pointer, you see that anything you hover your pointer onto, it shows you what it is. So here you see that it has registered that these are networking devices. So when you click on it, it shows a number of networking devices. One thing you have to know is that anytime you find in any book or any literature and you see in that book any of these round objects which have arrows that are showing in 4 areas that are meeting, you have to know that these devices or these things are representing routers. Now when you hover to the next place, you see end devices. When you click on it, you see a whole number of end devices, and we know that end devices are the devices that gives a user access, or that gives or concentrates a user onto a network. So sorry, when you go to the next one, you see components. Now Packet Tracer supports different types of components for different types of connections. It supports hardware, IT essentials, and therefore you see some motherboards here. And anytime you want to build a system or a board, or Internet of Things, when you have to build an Arduino board for sensor networks, Packet Tracer has some boards here which you can choose from. And then when you come to the next one, you see all these things. These are cables for connections. So when you bring it, you see that this blue cable, like I explained to you, as soon as you send it, it tells you it's a console cable. And the physical console cable is what I showed you to you the other time in the lecture, that connects to the console port of either a switch or a router or any other networking device which you can configure through the command line interface. Now the next one is a copper straight through. We know, or in our earlier classes, I informed you that when you want to make a twisted pair cable for a particular connection, or unshielded twisted pair for a particular connection, it has its own different color combinations that you are going to combine, and then you terminate it with an RJ45 connector. So I told you that straight through cables are normally used to connect unlike devices. When we say unlike devices, we want to say that devices that are not of the same kind. A switch is not of the same kind as a router. A router is not of the same kind as a hub. A hub is not of the same kind as a repeater. But when you want to make any connection between two like devices, which is a PC to a PC or a switch to a switch, or a hub to a switch, sorry, or a hub to a hub, or a router to a router, you use what you call the copper crossover cable. And then when you make connections to unlike devices, you use what we call copper straight through cables. And then when you come to the next one, if you have to make connections and then you are using a fiber optic as a medium, then you have to choose a fiber connector. And then you will have to know which devices, which networking devices also support fiber optics for a particular scalable network you want to build. So here is a phone cable, depending on the kind of connection you are making. If it is a dial-up telecommunication network that will need a telephone line, this is where you come and choose your telephone line. And then we have what we call the coaxial. The coaxial cable is the TV cable we have. Now, that is also a networking medium that are used for satellite connections, and we know that we have different types of coaxial. We have the coaxial thicknet, the coaxial thinnet, for different types of satellite connections or different kinds of network backbones. So we have the serial connectors. Now, these serial cables are used to stack routers. When we say stack routers, if you want to connect a router to a router in a server room, and you have some routers that you want to use to segment different types of networks, and all of them will have to be in a particular room, you use what we call the serial cable. Now, you see that on the serial cable, we have what we call the serial DCE and the serial DTE. The serial DCE is the data communication equipment, and then the serial DTE is the data terminal equipment. Now, the difference is that the serial DCE is one side of the of of the um of the cable that is connecting to another side of the router, whichever port is connecting to. Wherever the DCE connects, or the data communication equipment side connects, is where you perform what we call the clocking. As we go on in further videos, I will explain that. Now, we have other cables. We have the octal cable, we have the IoT, Internet of Things custom cable, and we have the USB cable. So all of them are dependent on the kind of network you want to build and the type of connections you want to do. Now, when you come here, you have miscellaneous, and the miscellaneous are miscellaneous devices you want to use. You see that you have some routers and a PC here. And then you look at the multi-user connection, which is a cloud. Now, clouds are normally, whenever you see a cloud in any book, you have to know it's a wide area network connection that has an internetwork connection, which we call the internet. And know that whenever you are building a network and there's the need for an internet connection, you need to put in a cloud to symbolize that. And there are certain configurations we do in a cloud. And normally it is at the ISP side where those configuration goes on. Good. So now when you come down, you want to see, so you have a router, you have, so when you click on this, you see a number of routers. When you click on this switches, you see a number of switches. And they all come in different versions depending on what kind of connection you want to make. But if it's a switch, it's a switch. So if it's a 29 switch, 2960 switch, or a PT switch, or a generic switch, or 2950 switch, it is the version you want that you choose. And then we have the hubs, and then we have the hubs, that these are the types of hubs that are showing. We have the wireless devices, and these are all wireless fidelity, microwave, and then other tower cell masts. Depending on the kind of wireless connections you are making, that will determine which one of the device you want to choose. And that is it. So the cloud, these are cloud, and then you choose which one. you want to use. Today, what we are going to do is that we want to choose a switch and work on it. So we want to pick a switch and we want to choose 2960. So you click on it and then you drag it, and then it sends you to the working page. As simple as that. So what are we going to do? We want to configure this switch. But when you click on this switch, you see the front of a switch. This is a switch, and this is a 24 port switch. Because when you count the ports, you see 24. And then when you come to the configuration, now this is the graphical user interface configuration, where if you want to give a name to a switch, when you put the name here, automatically it will go into the command line and fix the name there. But we don't want it, because we are going to do the configuration in the command line, and therefore we need to connect a PC to the switch. So this is a PC and this is a switch, right? Now we want to use a console cable or a rollover cable to connect to the console port of this switch, so that we can use a software to be able to have access to the internetwork operating system or the operating system of this switch, so that we can perform certain configurations. So we are going to pick a cable, and which cable? Console. Good. Now we are connecting a console cable from an RS232 port to the console port of the switch. Now I explained earlier that the RS232 port is the port behind the PC, which the console can make a connection. But then, if you are using a laptop for it, and the laptop does not have that RS232 port behind it, what you have to do is to get an adapter, fix the adapter on this cable, so that the RS232 port male adapter will fix to this cable, and then the end will be a USB, which you fix into a laptop. So you have an adapter that will fix, and then you can make a USB connection to the switch. Good. Now once we have been able to do that, let's go into the PC. I told you earlier that when you want to make a connection, you use any of the softwares, either a TerraTerm software, either hyperterminal software, or PuTTY software. Yeah, so you see this software. I said software available. When you go back to your slides, you see that the software available for the connecting to a network device is either the PuTTY, or TerraTerm, or Secure CRT, hyperterminal, or operating system X terminal. Any one of them, when you download it, you can use. Virtually, Packet Tracer has the hyperterminal software already embedded on the virtual PC. So you go to desktop, and then you go to terminal. As soon as you double click on terminal, this is what happens. So the bits per second, you maintain all the numbers here, 9600, the database and all that, and you say okay. Now this takes you directly into the switch. Good. So now this switch here, this prompt is what we call the user executable mode here. So the user executable mode prompt, this is here. Now when you give it the enable command, it takes you to the privileged executable mode prompt. So enable will change this greater sign to this hash sign. And that is what we want to do. So here, you say enable. Now this brings you to another point where the next command for you to move to the next prompt is configure terminal. Now this has taken you from the privilege mode to the global configuration mode. So at the global configuration mode, we want to give this switch a name. I told you earlier that names are given to devices for identification. So here, you see that here, it is still called a switch, but we want to give it a name. So at this prompt, you say host name Kwaps. So as soon as this command is executed, you see that the name of the switch has changed from switch to Kwaps here. Right? Good. Now, whatever you do on the switch, you need to whatever you do on the switch, you will need to declare the interface. Now the console port is an interface, so we want to go and give the console port a password. So you have to declare the interface before you can work within the interface. The command for the declaration of the interface is line con0. Now the line con0 means line console 0. The 0 simply means that it is only one port behind the switch. If there were two ports and I wanted to work on the second port, if I want to declare the interface, I'll say 1. So it's either 0 or 1, but because it's only one port, it is 0. So this means that we have declared the console port, and then now we are going to make configurations in the console. So the line console 0, what do we want to do in the console port? We want to provide a password for security. So we'll say that password Cisco. The next command is login. Now what it means is that you are telling the switch that in its console port, give it a password Cisco. And when should the password show? At login. That is when anybody wants to log in, the password should show in the console. Now we have given it a password, and the name of the password is Cisco. And then we go and say exit. Now exit simply means that we want to exit the line console interface, this one, so that we can declare another one to work on it. So the line con0, password Cisco, login, exit. Now I told you that switches and routers have virtual passwords, or sorry, they have virtual terminal sessions. We talked about telnet and secure shell. We said that early or earlier we used telnet, but the telnet was not secured. Now, an administrator can be at a remote area and log in into another computer in his network and work on it however he wants to do it. And it is these terminal passwords, or sorry, the terminal virtual terminal that they use to enter. And therefore, to avoid people getting into it, to avoid unauthorized users using those lines to enter into the network and do malicious things, you have to provide passwords for those virtual lines. So for every switch, the switch has 16 virtual terminal lines and routers have 4. So we want to declare the virtual terminal, or sorry, declare the virtual terminal and then put a password in it. So the next command is line vty 0 to 16. Now this is a range, 0 to 15, sorry. Now this is a range. We are saying that all virtual terminals lines from 0 to 15, we want to password all of them so that anybody who try to use any one of them cannot enter it. So line vty 015 password Cisco login exit. Good. Now we want to give the whole system, the whole switch, a password. The command is enable password Cisco. After doing that, we want to give it a secret password so that even if anybody has access to the password which you call the Cisco, it will also ask for a secret password which the person might not know. So the next thing is to do, or the next thing to do is to enable secret, and this time the secret password we want to call is class. So the password we have given to it is Cisco, the secret is class. Now there's one thing we have to do. Now these passwords we have given to it, we need to encrypt the password so that anybody who enters the device will not see the password in plain text, but will see them as scrambled. So the next command we want to do is to say that service password encryption. Now this command encrypts all the passwords, and when we finish, I'll go and show you. I will show you the running configuration, and you see that the passwords that I provided have been turned into illegible strings of letters, symbols, and numbers, which in actual sense is to take away the actual meaning of the passwords we have given for unauthorized users. Good. And then we want to give a banner. The last time I was telling you what a banner is, I asked you what a banner is. That a banner is a message that is given on a particular platform to represent something or to send a particular information. So we want to send a banner, and banners in network configurations for Cisco devices are supposed to warn off unauthorized users. So the command is that banner MOTD, which is message of the day. So banner message of the day, MOTD. Now, before you send a message, you give a space, and then you show the hash sign, and then you put your message in there. Say unauthorized access keep off. And then you end it with another sign. Good. Now, because we have not connected any other devices to them, we cannot go on to configure interfaces. And the configuration of interfaces will be in the next video I'm going to show you. When 2 or 3 devices have been connected together, then you see that device A is connecting to device B at this particular port or this particular interface, and therefore let's go and call the interface and activate the interface for it to come up, for them to be able to have a connection. So now, if we want to save all these things we have done into the NVRAM, the command is copy run start. So when you do copy run start, it saves the configuration. Now, we want to reload the switch, right? We want to reload the device and see if these configurations we have done have been kept on the device. So do reload, and then it says that proceed with reload. Yes. So we are restarting the switch, the device. Now when you press enter, or we want to close this. Good. Now let us assume that you have come, you are with your PC. Now somebody has come in, he has connected a PC, and then he wants to enter the switch. Now, so to enter it, you have to go to terminal, and then you say okay. Good. So now you are in the switch. As soon as you enter the switch, the first thing is the banner that you see. It says that unauthorized access keep off. That is telling you that that switch, the owner of the switch or the administrator letting you know that you don't have the right to enter it. Now it will ask you for your password. What password did we use? We said Cisco, and then you type enter. What password again did we use? You said class. No, sorry. So it says bad password. I've even forgotten the password I used, but let's see. So Cisco is what we used. Good. And because it was caps, that is why I think it was case sensitive. I used the capital letters. That's why it has come. So now the first password has gone through. That is the Cisco. Now it has taken me to this prompt. Now when I do enable, still trying to enter into the switch, then it asks me of another password, which is the secret password, right? So if you don't know it, you cannot enter it. So the secret password, we use class. Good. Now it's open for us. Good. Now we want to check how these configurations have been kept on it. So what the command is show run. Show run means show running configurations that have been done onto the switch. Good. Now it is giving you the version of the switch. It is giving you that the host name that has been given to it is Kwaps. Now see here, the enable secret password. See what we use class, but see the numbers that has been shown. So it is telling you that the command we used, service password encryption, has worked, and therefore, even if anybody comes and picks your device and wants to check the password that is in there, it will be scrambled this way. Now, the password, first we gave the secret password as class, and we gave the enable password as Cisco. Look at how it has also done the Cisco. So it means that the service password encryption command has scrambled the password so that unauthorized people can see it. Now, these are the interfaces on the router, on the switch. Sorry. Now, this switch has 24 ports. When I showed to you the physical, sorry, it has 24 ports. So you see all the ports are showing, right? But if you had gone on to make a connection with a new switch, you see that anywhere any device will be connecting, it will show you that the interface is up. The interface is administratively up. But this one is a single form of configurations that we are doing, and therefore the next video will capture the coming together of two or more switches and other devices, so that you will see how these configurations are done. Now it is showing that the banner on this device is unauthorized access, the line console password. The line console password is also encrypted, and then the password, the line virtual terminal password, are also encrypted. So this is how we are able to give a switch or a router an initial configuration. I will want you to pick devices or pick a switch. Now go into it like I showed you and perform the same configurations. We are going to meet tomorrow, and when we meet, we are going to discuss that, and the next video will show you the combination of two devices. So whilst you attempt and then you practice, then you use the slides as a guide for you to understand. The next thing you can do, right, is to get another switch. You can get another switch, and we know that two switches can connect to each other because they are like devices with a cable called the the crossover cable. When you connect two switches together, you use a crossover. When you connect a PC and a switch, you use a straight through. So here, we want to make a connection, copper straight through, copper crossover cable. You pick the crossover cable, you connect from port 1 of this switch to port 1 of the second switch. Now you can bring in a PC and connect from a PC to a switch. From a PC to a switch will be a straight through because they are unlike devices. So from this PC1 to this PC2, this switch 1 is supposed to be a straight through. So you pick a copper straight through and you connect from the fast Ethernet port. That is the networking card. It is like you have entered the cafe and you have pulled the cable, and you put the cable in your RJ45 connector or your networking card, and then you, where the cable is coming from for you to fix is from a switch. So you connect from your PC to a switch. Good. So whilst you do it, I will want you in the same way to use this PC1, come and make a connection with a console to this switch, and then work on it like you have done. So here you come and pick a console cable, you connect the console from the RS232 port to the console port of this switch. So this is switch 2. So now what are you going to do? The next thing is to go into the switch, you go to desktop, you go to terminal, and then you say okay. Now as soon as you go into it, you are in the switch. So the first command is enable. The next command is configure terminal. Now I want you to give this router Kwaps2 the name. So the command is host name Kwaps2. So you see that the name has changed to Kwaps2. So when you come to the board, this PC is Kwaps1, this switch is named Kwaps1, and this switch is named Kwaps2. So when you have done this, it means that this is Kwaps. When you come here, you can just put in here. For you to remember, if you are working on it, you just put in Kwaps here. And then you just put in Kwaps2 here. So that is it. So I want you to model what I have done. Go about it the same way I have done it. You do for Kwaps1 and you come to Kwaps2, but provide all the configurations I have done on Kwaps1 on Kwaps2 too. Now when you finish, you do what we call the copy run start. Anything you do on the switch, anything you do on the switch, and then you don't want to lose it, you say do copy run start. So it saves the configuration for you, and then anytime you continue. So this assignment is what I leave with you. Provide the configuration for the second switch. You go on Packet Tracer and do the same thing for the second switch. Provide all the configurations like I did for the Kwaps, and then you save your work and then you send it to me. So after you have done the work, you go to the Packet Tracer, file, and then you say save. Now, when you say save, you call it maybe assignment 1. So if you want to save it on your desktop, you save it. And then you send it to me in my email. So I will want to see that work by tomorrow before I'll go further with the next explanation on how to configure other complex networks with Packet Tracer for you. Thank you so much, and thank you for being with me. God bless you, and hopefully we meet in the next class. Thank you.